y equals g of x is shown below. Part A, define y equals g of x. So I'll start off, g of x is equal to curly brackets, because I can see there's three different rules here. We've got the purple horizontal line, which is going to be for where x is less than or equal to 4, minus 4, sorry. Then we've got the quadratic that's between minus 4 and 2. I won't include the line underneath the minus 4 here because I've already done so there. But I will put a line underneath the 2 there, and I'll come up with the rule for what the quadratic will be at that point in a minute. And then we've got the third equation for when x is greater than 2. Right, the purple horizontal line, that's nice and easy. I can see that the y coordinate is always just minus 5 if x is less than or equal to minus 4. The quadratic, let's do that one next. I can see we've got a turning point down here at the coordinate minus 2, minus 7. So that's straight away making me think of the square form of a quadratic of x plus 2 all squared minus 7. I'm getting this x plus 2 from the minus 2 there, and I'm getting the minus 7 from the minus 7 there. But I do know there might be a number at the front there that I need to work out. So let's check that. I'm going to choose a nice easy coordinate that I can substitute in. I'm going to substitute in the coordinate 0, minus 5. So the y coordinate is minus 5 when the x coordinate is 0. The 0 plus 2 is 2. The 2 squared is 4. Add the 7 to both sides. And I can see that a is going to be 2 divided by 4, or 1/2. So that is the equation of my quadratic, which I'm actually going to expand that out just so it's in a slightly more familiar and comfortable form. So let's expand those brackets to get x squared plus 4x plus 4. And we'll half each of those to be a half x squared plus 2x plus the 2 minus the 7. And the 2 minus the 7 is minus 5. Okay, next we've got the red line. I can see it's a straight line, so I'm thinking y equals mx plus c. I'm going to choose 2 points that are easy to read off. Let's choose the coordinates 2, 1. And we'll choose the coordinate 3, minus 1. The gradient, the change in the y divided by the change in the x. The gradient is minus 2. So m is minus 2. And substituting either of these coordinates in, I'm going to substitute the 2, 1 in. So y is 1 when x is 2. So c is 5. Because the 1 plus the 4 is 5. So I can substitute 5 in instead of the c there. And there we go, we've managed to define y equals g of x. It's equal to minus 5 if x is less than or equal to minus 4. It's equal to a half x squared plus 2x minus 5 if x is between minus 4 and 2, including the 2 as well. And it's equal to minus 2x plus 5 if x is greater than 2. Part B says to find the range, which is the set of y values. So looking at my graph, I can see that the biggest the y can possibly be is 1. Can't be any bigger than that. And then in terms of the smallest it can be, well, I can see this red line here is going to be getting smaller and smaller and smaller forever. So there's no lower limit on what y can be, but the upper limit is definitely 1. So I'm going to say g of x has got to be less than 1. It can equal 1 at that point when x is 2. So I will put a line underneath. So g of x is less than or equal to 1. And then the final part of the question, solve g of x is equal to 0. I can see that my function is equal to 0 in 2 places, here and here. This one is quite easy to solve. That's my straight line. That's my minus 2x plus 5. So that's going to be equal to 0 when x is 5 over 2 or 2.5. Now for the other solution, that's where my quadratic is equal to 0. So a half x squared plus 2x minus 5 is equal to 0. Let's just multiply through by 2. And that's not going to factorise, so we'll use the quadratic formula here to solve this. And we find that x is either 1.74 or minus 5.74. The minus 5.74, I'll ignore that solution because the quadratic isn't valid when x is less than minus 4. It's only valid between minus 4 and 2. So it's the 1.74. So my 2 solutions are 1.74 to 2 decimal places, or 2.5.